Okay, welcome to Solving Simple Equations, lesson 1.1 in your Big Ideas Blue math book. A couple of things we want to make sure that we remember as we head into Unit 1 are our rules about inverse operations. So addition and subtraction are inverse operations, and multiplication and division are inverse operations, meaning that you can use these inverse operations to cancel each other out. So the first example we're going to look at under solving equations is using addition or subtraction to solve for x. So in this first example, in my simple equation of x minus 7 equals a negative 6, I'm going to recognize that I'm going to use the addition property of equality here by getting rid of this negative 7 because I want to get x by itself. That's the whole purpose of solving these equations. I have to get x by itself, which means I have to get rid of this negative 7. So I'm going to undo the subtraction using the addition and property of equality. I'm going to undo that subtraction of taking away 7 by adding 7 to it. And because I have done that to the left-hand side of the equation, and the whole goal is that I need to keep these balanced to keep them true, I need to add 7 on this side as well. Once I've done that, I can simplify. Since that is now essentially gone, I have got x equals, oops, no, not 7, x equals 1. We can look at one more using a decimal. So I've got y plus 3.4 equals 0.5. Again, in this case, I have a positive 3.4. I still need to get the variable alone by itself. So I'm going to undo this to get it alone. So I'm going to take away 3.4 from each side of the equation. That'll essentially get that down to nothing, which will leave y alone. And I will get y equals a negative in this case, because the negative 3.4 is larger than the 0.5, 2.9. All right, moving on to solving equations using multiplication or division. So the same idea here, I want to get equations by themselves, meaning that whatever is happening with that variable, I need to undo that. So if I have a negative 3/4 n equals a negative 2, I have to recognize that currently that negative 3/4 is being multiplied by the n. I have to undo that, so I get n by itself, and I undo this multiplication by dividing, and of course when you divide with a fraction you have to use the reciprocal. So I'm going to multiply by the reciprocal of negative 3/4, which is essentially like your division that we just talked about. And then because I did that on this side to get rid of that negative 3/4, I am going to do the same thing on this side. Multiply my negative 2 by the negative 4/3. So now that this is gone and has left n by itself, I now get, well, negative 4 times a negative 2 is 8. Okay, and then my 3 will just stay a 3. So n equals 8/3. I can also do problems like this using symbols that represent numbers. So let's say we had pi times an unknown x equals 3 pi. And you don't even need to know what pi is in this case. You just have to remember that you're trying to balance the equation. And so in this case, I have to get x by itself. It's currently being multiplied by x. So I will divide pi to get it kind of, again, to undo that multiplication, which means I'm also going to divide 3 times pi by pi on this side, And again, that undoes that. And we've got x equals 3. So the solution is 3 when we simplify that. Moving on to number 3, identifying the solution of an equation. So what value of k makes the equation, this equation here, k plus 4 divided by 2/10 equals 5, true? So in this case, you just got some multiple choice answers. You need to decide which one makes it true. Rather than plugging in each one, I would recommend just, solve the equation and then hope that the correct answer is here. So we're going to work the equation down here. K plus 4 divided by 0.2 equals 5. So in this case, I've got two like terms that I need to combine before I start to isolate the k by itself. So I need to actually do the math of 4 divided by 2/10, and that is 20. And then rewrite the rest of the equation as it is. Do one step at a time as you're doing these. And now you will recognize the equation like we had back in example 1. So now I need k by itself. It's being added to a positive 20, so I subtract 20 to undo that. Subtract 20 over here to keep that equation balanced. And k is equal to negative 15. And that would be our correct answer up there, is A. So when we take these and turn them into real-life applications, you might get something that looks like this one. Okay, so the melting point of bromine, which here you can see is negative 7 degrees Celsius, is 1/30th of the melting point of nitrogen. So we need to take this information, we need to write and solve an equation to find the melting point of nitrogen. And these are a little bit trickier, but if you take them slowly and identify the vocabulary words within the problem and associate that to numbers and symbols that we know for math and what they mean, it becomes a far less tricky problem. So we've got the melting point of bromine is. Okay, so the melting point of bromine, which is negative 7 degrees Celsius, is. So that's the first part of my problem. Negative 7 is the melting point of bromine. Is, in math we know, is means equal to. So that's the first part of our equation. So the melting point of bromine is 1/30th. So that's the second part on this other side, is 1/30th of, we know, means to multiply. Okay, so you can either put your multiplication symbol here or just write, if it's a variable, you can write it right next to that 1/30th. Is 1/30th of the melting point of nitrogen. We need to find the melting point of nitrogen. So we don't know the melting point of nitrogen. That's what we're trying to solve. That's our variable. So I can put an n there. So if we reread the question and convert that into mathematical symbols here, see the melting point of bromine, negative 7, is 1/30th of n, which is the melting point of nitrogen. And now we can just go ahead and solve it as we would have back in step 2. We are going to undo this multiplication. So it would look something like this. So we've got our negative 7, and we're going to multiply this by 30 because we are currently working with 1 divided by 30, right? So we'll multiply a whole number 30 times that 1/30th. And I'll keep that in parentheses there. And since we multiplied by a positive 30 over here, I'm going to multiply by a positive 30 there. So that has now gotten rid of this. Positive 30 times a negative 7 gives me a negative 210 equals n. So the melting point of nitrogen is negative 210 degrees Celsius. If you need to find some more sample problems and you're looking in your Big Ideas book, you can find them under section 1.1.